Hello and welcome. This is going to be our quiz review for the energy curves quiz. On that quiz, we're going to see a lot of graphs that look just like this. So we need to be able to understand what this graph represents. So this graph is the graph of the temperature of some sort of substance as we add heat to it. Or sometimes you see this over time because something is sitting on a hot plate and more heat is being added to it. Or heat could be removed as well, and we would see this graph go in the opposite direction if something was sitting in like a refrigerator. So you should definitely recognize that the slanted sections are when we are in a consistent phase and the temperature is just able to increase. The slope is then going to correspond to the specific heat of that substance. So that brings us to question one. The heating curve shown was generated by measuring the heat flow and temperature of a solid as it was heated. The slope of the blank segment corresponds to the specific heat capacity of the liquid. So only in this phase right in the middle is our substance a liquid. So it is the line segment from C to D, which has a slope. Now the steeper would actually correspond to a lower specific heat because it being steeper means that it's easier to increase the temperature, and a high specific heat means it's hard to increase the temperature. It's how much energy we have to put in to go up 1 degree. So it's actually the reciprocal of the slope gives us the specific heat. Let's just keep going through these questions. So phase changes B to C, and D to E are associated with the temperature increase, or not associated with the temperature increase because the heat energy is used up to, correct answer here was B, break bonds between molecules. Those are called intermolecular bonds. And those are our strongest bonds, which are things like covalent bonds or ionic bonds. Option E is tempting, but the intra is bonds between molecules. So those are the weaker bonds, like hydrogen bonds between neighboring molecules of like water, for example. One thing that you should know for the quiz is that in those flat sections, we are increasing the potential energy of the substance. And then that's for the flat sections. For the slanted sections, we're increasing the kinetic energy at a molecular level. That's what temperature is. So yeah, be able to differentiate between times when we're increasing the potential energy by breaking the bonds or increasing the kinetic energy by just simply increasing the temperature. All right, now we do have some here that are going to require some math. Your two main equations are going to be Q equals MCAT and, oh, this is supposed to be a T. Q equals MCAT and Q equals M delta H, which is for any phase changes. So let's look at number 3. I think maybe, yeah, we'll just do 2 of these. Okay, so number 3. So I've got 1 mole of water at 25 degrees Celsius. It's converted to steam at 115 degrees Celsius. So to figure this out, we have to do 3 separate calculations. One calculation to increase the water from 25 to 100. One calculation for the phase change at 100, and then a third calculation to increase the temperature from 100 to 115, and then we'll add them all together. So when the temperature is changing, we use Q equals MCAT, MC delta T, and then at the phase changes, we use Q equals M delta H. And then these values are specific to the phase of our substance. So I've got 1 mole of water, but I only know these C values in grams. So I can convert 1 mole to grams by multiplying by the fact that 1 mole is equal to 18 grams. That's a very simple unit conversion there because just moles cancel out and I'm left with 18 grams. So 18, the specific heat of liquid water is 4.18. And the change in temperature here, that's a 75-degree jump. So I'll multiply those to get joules. Now here, I'm going to take the mass for the heat of vaporization. That's given in kilojoules per mole. So to keep this in moles, I might convert back to joules per mole. To go from liquid water to steam is this number right here, the heat of vaporization. So that's actually 40,670 joules per gram, and we have 18 grams. And then for this last one, Q equals our 18 grams times the specific heat of steam, 2.08, times the change in temperature of 15. All right, I'll pause to do these calculations. All right, while I was doing the calculations, I realized I used the wrong mass unit because I was given right here the heat of vaporization per mole. So instead of using 18, I just used 1 mole. These are the joule requirements for each of those segments, and now I'm just going to add them up. 5,643 plus 40,670 plus 561 gives me a total. Oh, I accidentally hit times. So we want that for a plus of 46,874 joules, which is equal to 46.9, rounding up, kilojoules. To go joules to kilojoules, we just move the decimal place 1, 2, 3 times because there's 1,000 joules in a kilojoule. That's how the metric system works. And that matches option D there. Okay, I know I said I would do 2 more, but I think I'm going to leave it there since we covered both equations. The next one just has it because it goes ice to steam. You have to do 3 separate Q equals MCAT equations and then 2 separate phase change calculations. And then for 5, you have a fixed amount of heat, and then you have to solve for the delta T in Q equals MCAT. We'll hopefully include some of that in our next video for the test, but that's above the level of this quiz. So I'm going to just call it good there, end this video, and have a good rest of your day.